All right, let's jump right in. For a long time now, there's been this really fascinating, kind of underground debate happening in cosmology. You could call it a cosmic duel, a showdown between two completely different ways of thinking about what really makes the universe work.
And really, it all comes down to this one huge question. What's in charge? Is our universe shaped by the slow, steady, relentless pull of gravity? Or is it sculpted by the flashy, dynamic, crackling power of electricity?
I mean, think about it like this. In one corner, you've got gravity. It's the patient builder, slowly gathering up cosmic dust over millions of years to build stars, planets, and whole galaxies. And in the other corner, you have electricity, the flashy artist, painting the universe with these incredible, lightning-fast jets and filaments. It's really the classic showdown, right? The marathon runner versus the sprinter. Okay, so to really get this debate, you have to give the challenger some serious credit. The electric universe theory, it makes some really powerful points that have kind of forced mainstream science to sit up and take notice.
And what's so compelling is how much the electric universe folks, the EU proponents, they got right, and way before it was a mainstream idea. They were the ones pointing out, hey, space isn't empty. It's actually a plasma, a sea of charged particles that can conduct electricity. They saw that the cosmos is woven together with these incredible filaments and threaded structures. And they were right that there are actual electrical circuits in space, stuff like Birkeland currents, which, power our own auroras. They saw that the patterns you can create in a plasma lab right here on Earth, well, they show up again on these unimaginable cosmic scales.
So the EU proponents, they look at all this evidence and they say, see, it's obvious, electricity is running the whole show. But then, this other idea called motion theory comes along. It looks at the exact same evidence and says, whoa, hold on. Yeah, we see all that too, but maybe what we're actually seeing are the signatures of synchronized motion. And this is where the story gets really interesting. So instead of a fight between these two forces, motion theory asks us to kinda listen for a totally new kind of cosmic rhythm. It completely reframes the whole argument. And this leads to a pretty radical idea. What if it's not gravity versus electricity at all? What if they're both just different expressions, different frequencies of the very same underlying reality? You see? Not a duel, but a duet.
Now, to really wrap your head around this, let's do a quick translation of terms. In motion theory, charge isn't some property of a particle. Nope, it's just an imbalance, an area that's out of sync with the cosmic rhythm all around it. Think of it like a single ripple on a perfectly still lake.
And that imbalance, that ripple, well, that creates what we call voltage. But here, it's just the pressure for that out-of-sync area to get back in step with everything else. It's a sync pressure. It's the universe's natural tendency to seek harmony.
And finally, current. It's not just a bunch of electrons flowing through a wire. In this new view, it's the flow of the synchronization itself. It's coherence moving through the system, trying to restore that lost balance. So electricity is really just motion looking for the quickest, straightest path to get back in sync. And once you have that translation in mind, the duel, well, it turns into an orchestra. Electromagnetism is your high-frequency instrument, like a lead guitar. It's fast, it's sharp, it's what sculpts all the cool surface details, the jets, the filaments. But gravity is the deep, low-frequency baseline. It's what slowly brings all the bulk mass together, building the grand structures. It builds the stage for electricity to play its solo. They aren't rivals at all. They're just different sections in the same cosmic band.
Okay, I know, that sounds pretty cool in theory, but how does it actually work in the real world? Well, let's test this idea on something we all recognize, our sun.
The electric universe theory makes a really bold claim here. It says the sun is not a nuclear furnace burning from the inside out. Instead, it's powered externally, like a giant light bulb in space that's plugged into massive galactic currents.
But motion theory looks at the clues we're getting from inside the sun and kind of pumps the brakes. For one, the stream of neutrinos we detect coming from the sun, it perfectly matches what we'd expect from nuclear fusion deep in its core. Then there's helioseismology, basically studying sunquakes, which shows us an interior that's incredibly dense and hot, just like a fusion model would predict. And all that amazing electromagnetic fireworks we see, it's all happening on the surface, on the sun's skin. It seems to be an expression of the sun's power, not the source of it.
So the verdict from motion theory is this really beautiful blend of both ideas. Yes, the sun is absolutely fusion-fed at its core, held together by gravity's deep, steady groove. but it's also fiercely, brilliantly, electromagnetically expressive right there on its skin. It's not an either-or situation. It's both, working in perfect harmony.
So let's zoom out one last time. This whole idea of layers, it doesn't just apply to the sun. Motion theory actually proposes a complete model of reality, and it's built in layers.
They call it the motion stack. Right at the bottom, you have the fundamental motion field, the substrate of everything. On top of that, layer 2 is gravity, that slow rhythm building the big structures. Then, once you have those structures, layer 3, electromagnetism, comes in to express fast, high-frequency energy on them. Above that, you get chemistry, handling local energy budgets, and then right at the very top, you get biology and technology, life itself, creating these complex loops that can actually influence the layers below.
And this brings us to the most important point. The electric universe theory does an absolutely brilliant job of describing what's happening in layer 3, that world of electromagnetism. But what motion theory says is that to get the full picture, you can't just fixate on that one layer. You can't just listen to the lead guitar. You need all 5 layers. You need the whole orchestra.
And so we end up at this final synthesis. We started out thinking this was a duel between 2 rivals, but it turns out we were listening to a symphony the whole time.
Because in the end, these aren't opposing forces at all. They're just different ways that the one underlying reality of motion expresses itself. Electricity, that's how motion expresses sharpness, the crisp edges of a filament, the focused beam of a jet, the sudden crack of lightning. And gravity, that's how motion expresses commitment, the unwavering dedication of an orbit, the slow, certain pull of collapse, the deep formation of structure.
So, what truly runs the cosmos? Gravity or electricity? Well, maybe the answer was never either or. Maybe, underneath it all, it was always just motion. And electricity? Well, that just happens to be one of its absolute favorite and most spectacular riffs.